You might be tempted to pronounce this as Euler's formula, but it's actually German, and so it's pronounced Euler's formula. And it says that V minus E plus F equals 2. And the V stands for vertices, the E stands for edges, and the F stands for faces. And this formula will work with any of our solids. So just to prove that, I'm going to start by looking at this one right here. Let's count the vertices. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that would be 8 minus E, which is edges. So in the edges there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Plus F. F is the number of faces. Let's just clean this up a bit so you can see. Well, it's kind of like a dice. So you've got 1, 2, 3, 4, 5, 6, just like a dice. Now, does that all equal 2? Well, 8 minus 12 is negative 4, plus 6 is 2. So it does work, and we can use that to solve. So let's have a look at this question. Find the number of vertices. Well, let's start with vertices. So vertices is 1, 2, 3, 4, 5, 6. Edges is... oh, wait a minute, that's not 6. I only did the top ones, didn't I? There's also 6 on the bottom. Another 6 down here. So the vertices is actually 12. The number of edges is going to be 1, 2, 3, 4, 5, 6. And then another 6 on the bottom. And then another 6 going up and down, so that altogether that's 18 edges. And then the number of faces, again, let's tidy that up a bit. Well, there's 2 faces top and bottom, so this yellow and that yellow, and then there's 6 of these, 1, 2, 3, 4, 5, 6. There we go. I'm not going to bother doing number 2, it's pretty simple. Diagonal of a prism. So there are times when you're going to be asked to find that length right there. And let's just draw a picture. Well, first of all, if you remember, the Pythagorean theorem says that a squared plus b squared equals c squared. And from that, I've shown you my quick method to solving a Pythagorean theorem problem. So if you've got a triangle like this, and that's 3 and that's 4, then to find the hypotenuse, this one here, you basically do the square root of 3 squared plus 4 squared, and that will give you 5. Now let's see how that applies to this problem. So how do you attack this problem? Well, it's very, very similar to the one where I said you just do 3 squared plus 4 squared. The only difference is you now use 3 numbers. So you basically do 6 squared plus 8 squared plus 10 squared. And when you put all that in your calculator, you're going to get, let's see, 36 plus 64 plus 100, which is the square root of 200. And that simplifies further, but I'm not going to do that right now. We have to be super careful with this problem. And I just want to have a quick reminder of what happens when we have a situation like this. So what about if I had, let's say, 12 here and a 13 here, and I said, can you find x? How is this different to the last one? Well, you'll notice that 13 is the long hypotenuse, and so when we find our x here, we actually have to do a subtraction. So this is actually going to be 13 squared minus 12 squared, and that will give us our x, which in this case I believe is actually 5. Perhaps a better way to think of this is the traditional method of Pythagorean theorem, which says a squared plus b squared equals c squared. Now c is that long 13, so that's 13 squared, and a is, we could call the x, and b is the 12 squared. So that's x squared equals 13 squared, I'm going to subtract the 12 squared over there. So x squared is going to equal, let's see, 169 minus 144. So x squared equals 25, and when we take the square root, then we'll get our x equals 5. So I'm going to do something similar with this picture right here. The thing I want you to bear in mind is, in this one, rather than giving us the three sides of the rectangular prism, they've actually given us two of them and the diagonal. See this red diagonal right here? In which case we're going to have our a squared plus b squared plus c squared equals the diagonal squared. So that means we're going to have 12 squared plus 7 squared plus, we don't know what the c squared is, equals the diagonal squared, which they gave us was 15 squared. And so we're going to solve for the c squared, and we're going to get 144 plus 49 plus, we don't know what the c squared is, equals 225. And now let's tidy that up a little bit. So 144 plus 49, and then we're going to take that to the other side, so we're only going to end up with c squared equals 32. So c is going to equal the square root of 32, which can be simplified, and actually isn't that the same as square root of 16 square root of 2, which is equal to 4 root 2. Now before we attack this three-dimensional distance formula problem, I want to recall a cool method that I showed you a while back of how to do distance between 2 points. So let's say we've got something like this, and I give you 2 points and I say find the distance. Well, the trick I showed you was make yourself a fake little triangle like this, and you say, okay, how far is it from 1 to 4? That's a distance of 3. How far is it from 3 to 7? That's a distance of 4. Well, to find this hypotenuse, or the x, we just do square root of 3 squared plus 4 squared, which equals 5. So with this problem up here, we're going to do something really, really similar, except there's an extra dimension. There's an x, y, and a z. So I'm going to say, okay, well, it's going to be the square root of, how far is it from 0 to 2? That's 2 squared. How far is it from 0 to 8? That's 8 squared. And then 0 to 5. That's 5 squared. So that is square root of 4 plus 64 plus 25. And I'll let you finish that one. And let's set up the next one as well. Same deal. Don't worry about the negatives here. Just think distance. How far is it from 6 to 4? It's a distance of 2. So 2 squared. How far is it from 11 to 6? That's a distance of 5. How far is it from 3 to 12? That's a distance of 9. And again, I'm going to let you finish the rest of that. So that's distance formula. Now we need to talk about how to do the midpoint. And midpoint is average. So can you find the average? And again, let's just review. If I gave you 2, 6, and 4, 12, how do we find the average? Well, with 2 dimensions here, remember this is x and this is y, we're just finding the average of the x's first. Well, what's the average of 2 and 4? That's just 2 plus 4 divided by 2, so that's 3. Then find the average of 6 and 12, which is 6 plus 12 divided by 2, so that's 9. So that's how we do the midpoint in 2 dimensions. Now let's try that same thing, but in 3 dimensions now. So now for midpoint, we're going to find the average. So what's the average of 0 and 2? Well, that's 0 plus 2 divided by 2, which is 1. Then we're going to do 0 and 8. Well, it's pretty easy to see the average is 4. And then 0 and 5, and the average is 2.5. Now let's do the same over here. So what's the average of 6 and 4? That's 5. What's the average of 11 and 6? Let's just do that. 11 plus 6 divided by 2. 11 plus 6 is 17. So that's going to be 8.5. and then 3 and 12, 3 plus 12 divided by 2. So that's 15 divided by 2 is 7.5. Nice and easy.